Hi class, hope you guys are all doing well. Got another video for you today out of chapter 6, actually the last one out of chapter 6. We have midterm 2 next week. Look for a study guide for that coming up in the next 24 hours for sure. That test will open up on Monday, be open Monday to Monday. But let's knock out section 6.2 first, which covers applications of the normal distribution. We learned about that normal distribution at a basic level in the last video. Maybe. Oops, that was not what I wanted. Close. Let's go over here. There we go. But we've got a couple goals in this lesson today. The first one is to find probabilities given a real-world scenario. That'll be very similar to what we did in section 6.1. Only difference is instead of being given z-scores, we're going to be given real-world values, and we're going to then convert those to z-scores. The second application we're going to look at is to find cutoff scores. So say we want to know what is the top 5% of SAT scores, something like that, a cutoff score, or what is the bottom 10% of income in Warsaw. Something like that. We can find cutoff scores. And then we can use that, we can use the standard normal distribution to do that as well, provided the data is normally distributed. So let's go ahead and get into it. Again, first thing we want to do is we want to look at finding probabilities using the standard normal table. And we're going to make heavy use again of that standard normal table. I believe it's 769 and 770 or 779 and 780. I don't remember exactly which one of those. I'm pretty sure it's 769 and 770. But if not, it might be 779 and 780. We're going to make heavy use of that table. In this type of problem, our goal boils down to this. We want to convert the given numeric values to z-scores, and then we're going to do exactly what we did back in section 6.1. It's just adding one more step onto what we did in section 6.1. And again, I do put here the formula for calculating a z-score. Z is equal to the value minus the mean divided by the standard deviation. That is how we find a z-score. Let's take a look at a few examples here. All right, so an adult has on average 5.2 liters of blood. We want to assume that variable is normally distributed and has a standard deviation of 0.3. Our job is to find the percentage of people who have less than 5.4 liters of blood in their system. This is an example out of the textbook, as will be everything in this lesson. So hopefully you've kind of read and have a general idea of what we're going to do here. The first thing you want to do in these, which I don't do a great job of doing in my additional exercise that I typed up, you want to draw a picture. All right, so let me just draw what this is going to look like, the scenario. So we've got, here's what would be like the x-axis. Got a normal curve. Doesn't have to be pretty in any way, shape, or form. That one kind of sucks, but it will work. Right here in the middle is my mean. Now, I want to know what percentage, here's 5.4, what percentage people will have less than 5.4. That means I'm going to shade, and let me get a highlighter here. I want to know what is in here. Hopefully you guys like my writing a little better this time than the last time. I actually have a pen now. Let's see, go back into the pen, put it on red. What's our black, I mean. So we have a problem where it's to the left, which means going back to section 6.1, once I convert this 5.4 to a z-score, I'm just going to look that z-score up in the table and I'm going to be done. So I have here a normal distribution with mu, and I probably should have done this from the beginning, but the average mu is 5.2. The standard deviation, sigma, is 0.3. And my x value, this time there's only one of them, but the x value is 5.4. So first thing I do is I find the z-score associated with 5.4. So z is equal to 5.4 minus 5.2 all over, 0. I need to get used to writing with this thing, 0.3, which if you simplify that, 5.4 minus 5.2 is 0.2. 0.2 divided by 0.3 is approximately a z-score of 0.67. So what this boils down to is I've just got to find the probability to the left of 0.67. This is a less than problem, a left problem. Again, all we do, we consult our table. I don't need to subtract from 1. I don't need to do anything between. That's all I've got to do, consult the table and go from there. So let's go ahead and do that. 0.67. Keep those. Go in here. Might need a little bit of zoom there. So 0.67. 0.6. 0, 1, 2, 3, 4, 5, 6, 7. The associated probability here is 0.7486. All right, so let me go ahead and write that in here. Slideshow from current slide. So the probability is 0. Oh man, I don't remember what it was. I guess we will have to look at it again. Keep that. 0.7486. Okay, 0.7486. Try that again. 0.7486. Change this back to black. It asks for a percentage, though. So we multiply by 100, aka move the decimal place over twice. The correct answer, 74.86%. And we're done. Nothing more to do on that one. It is complete. With that, let's take a look at another one. So each month, an American household generates an average of 28 pounds of newspaper for garbage or recycling. Seems like a lot. Assume the variable is approximately normally distributed and and the standard deviation is 2 pounds. If a household is selected at random, find the two probabilities here between 27 and 31 and more than 30.2. So again, first thing I'm going to do now, instead of doing the drawing, first I'm going to write down my average and my standard deviation. So looks like in this case, the average is 28. So mu is 28. My standard deviation, sigma, is 2. So for A, my drawing will look something like this. In the middle, I've got 28. I want to be between 27 and 31, so doesn't have to be drawn to scale. Here, 27 is just as close to 28 as 31 is. Doesn't make any difference. Z-scores here. Let's see, I've got X1 is 27, and X2 is 31. This time I've got two different X values. It's a between type problem. So starting with 27. So Z1 is equal to 27 minus 28 over 2, which is negative 0.50. Z sub 2 is 31 minus 28 all over 2, which is equal, which is equal to 1.50. So I've got negative 0.50, 1.50. So really this boils down to solving the problem. Probability that negative 0.50 is less than Z is less than 1.50. This is a between problem. We're looking for this area right in here. So we take the area to the left of the smaller, of the higher z-score, minus the area to the left of the smallest. That will tell me the total area that I'm interested in. So now, going back to the pen tool real quick. So I need to look up 1.50. I need to look up negative 0.50. Let me just do that. End the show. Keep the annotations. So first off, 1.50. Get my highlighter tool out here. 1.50. Hey, do it. I'm not going to do it. That's okay. 0.9332. 0.9332. 0.9332 minus, we'll consult the chart again for, where's my, there it is, negative 0.50, 0.3085, 0.3085, minus 0.3085, get my phone out here for a calculator, 0.9332 minus 0.3085, 0.6247. Find the probability. The probability as a decimal is just fine. We do not need to go any further. We're not asked for a percentage there, so we're going to be happy right there. Let's resume the slideshow now. So from the current slide, and let's hit the next slide. There we go. So a decibel is a measure of the intensity of sound. Average number of decibels at a full concert is 120. Let me just write that down. It just dawned on me, I did not do the last part of that problem, did I? Let's go back in time. Let's see, so more than 30.2 pounds. I need to do that. Don't know how. I almost forgot about that. Let me do a little bit of erasing here. I'm going to erase some of the... Actually, I can probably safely erase everything. If you want to pause it real quick, go ahead and do that. I'm going to clear all the ink from the slide. No, it won't let me do it. All right, well, I'll find a way. Do you not like my ink? Must not like it. All right, well, let's just go ahead and do it here. I guess that's weird. B. Kind of smaller drawing. Holy cow, my phone's going wild. 28. Let me just mute that real quick. Too much racket. 30.2 is right there. And I want to know what is more than that. So let me get my highlighter out. I want to know what's in here. And that's what I'm trying to find. So that's a greater than problem. I'm going to find the probability to the left and subtract it from 1 is what I'm going to end up doing. Let me get my pen back here. So I need to first, again, find the z-score. So x here is 30.2. So z is equal to 30.2 minus 28 all over 2. Hammer that in my calculator. Should be 1.2, but I'll make sure. Or 1.1 minus 28 divided by 2. It is 1.10. So what I'm asked to find here is the probability is z is greater than 1.10. That's going to be 1 minus whatever I find in the table. Just thinking back to the methods of 6.1. So let me just end the show. That's probably why I couldn't erase it. I kept the annotations. Lesson learned there. Let's scroll it. And at 1.10, 8.8643, 0.8643, which is, first off, from current slide, which is 0. 1 is the probability there. And I guess I'll just go with red. I don't want to erase it and change it. Now, where was I? Back to the next one. So just real quick recap. We found the z-score. It's a more than problem, so I did 1 minus the value in the back of the book. Next slide. All right, so here's the decimal one. So approximately how many will be less than 112? So is 120. Sigma, the standard deviation, is 6. We want to first draw our picture. Can draw it a little bit bigger here since I got plenty of room. And again, does not need to be a work of art. Oh, that one's pretty good. Here's 120. Over here, somewhere to the left, is 112. And I want to know the area in here. So think to yourself real quick while I'm filling this in nice and pretty. How would I do that? Man, I love this new pen. Oh boy. Right, I spoke too soon. Pen, you still black? You are. Okay. So you're thinking about that. What you got to do, find the z-score. It's an area to the left, so we just look it up in the table. So 112. So z is equal to 112 minus 120 all over 6, which is going to be, let's see, 112 minus 120 is negative 8. Negative 8 over 6 is negative 4/3, which is a decimal is negative 1.33. If you're typing this into a calculator, by the way, you type it in as 112 minus 120 divided by 6 is how you type that in. I don't think I went over that. But just for order of operation's sake, do the top of the fraction first, then divide it by 6. It's negative 1.33. So I'm going to look up negative 1.33 in my table, and that's going to be my probability value. It says if 100 concerts are selected, approximately how many have a decimal. So let me just pop out of here and look up the table real quick. Keep those annotations. Let's see here. Negative 1.33, 1.30, 1, 2, 3.0918. 0.0918, 0.0918. So now it asks actually if we did it 100 times. So we'll just take that proportion, that probability, times 100, and we would expect it to happen 9.18. Oh, geez. Which is about 9 concerts, I guess, is the context here. So about 9 concerts. We wouldn't say, as mathematicians, oh, at 9.18 out of the 100 concerts. It doesn't make sense in a real-world context. So we rounded down to 9 is where we expect it. Let's see. With that, I think we're ready to look at cutoff values. You can do it. There we go. So now we're looking at cutoff score type problems. The goal there is to find a minimum or maximum, or both. If it's a between type problem, both. Allowable values. And to find those, we're going to do something I call reverse lookup. So this time, so in the previous, I should start from the top. In the previous problems, we were given values. We found z-scores to find probabilities. In a cutoff score problem, we're going to be given, oftentimes indirectly, target probabilities. We're going to find the z-scores and use those to find cutoff values. And I think something I didn't write in here, the formula we're going to use, guys, is x equals mu plus z times sigma. And I should probably derive that. So the way I find that is z equals x minus mu over sigma, multiplying both sides by sigma to get rid of that fraction, I get z sigma is equal to x minus mu, and x equals mu plus z sigma comes directly from that. But this will be the formula we will use then to find our cutoff scores once we found our z-score. Drawing a picture will be extremely useful here, I think even more so than it was in those previous problems. You could probably get away with doing those problems without making the drawing if you're feeling confident. These ones you're going to have an awfully hard time without a picture. And an important note, when we think about interpreting our drawings, that table we've been making heavy use of can only be used to find probabilities to the left. So if we're looking for an area to the right, for example, we need to convert that to an area to the left. All right, with those things out of the way, let's take a look at finding cutoff values. So to qualify for Police Academy, candidates must score in the top 10% on a general abilities test. So assume those test scores are normally distributed. The test has a mean. Let me go ahead and write that. The mean, mu, is 200. The standard deviation is 20. We want to find the lowest possible score that will qualify. So what we want to do, as far as the picture, whoa, what just happened there? Erase that. Not sure what that was about. Pen, let's try that again. There we go. Oh, that's crappy, but that's okay. We want to be in the top 10%. We want to be somewhere out in this right tail. We want 0.1000, 10% of my, I want to be in here. In order to be accepted into the academy, I've got to be in here. But remember what I just said. The standard z table is not going to help me with this 0.1000 here. That is not going to work. What I actually need to find from the z table, what I'm going to reverse look up, is 0.9000. Because I can find things to the left. This is what I'm looking for. All right, so I need to find the z-score where the area to the left is 0.9000. So with that, let's go ahead and reverse look up 0.9000. So end the show, keep the annotations, come over into here. Well, I know it won't be a negative z-score because I know I'm above the mean. So let's take a look here. Let me get a little bit less zoom on this. Let's see, there we go. So we're looking for 0.9000. So let's see here, 0.88, 0.9032. So let's come up into this row and come over to the side. Let's see, 1.28 has a z-score of 0.8997. That's pretty darn close. 1.29 will be here a little bit over 0.90. Now, we have typically erred on the side of picking the one that's closest. However, if I'm at the 0.8997, I'm technically not in the top 10%. This is too low. Even though it's the closer one, it's too low. It doesn't put me in the top 10%, whereas this one does. So the z-score that I'm going to choose is 0.9015. Actually, I should probably check that. They may still be going with a close method here. I'll be right back. do take the closest value, which I disagree with, but since the book does it, I'll do it. If you're at 0.8997, I guess you're close enough. So we'll take 1.28. So we reverse looked up. The closest was 1.28. So Z is 1.28. So my cutoff score then is, come on now, X equals mu plus Z sigma, which is equal to 200, come on now, plus 1.28 times 20. Hammer that into a calculator. 1.28 times 20 plus 200, 225.6. Which we would then round up to 226. You would never round down. If you round down, I guess not for a top percentage. It's going to depend. I probably shouldn't have put it that way. In this case, you wouldn't want to round down because you might then kick yourself out of the top 10%. Like we're thinking we want to be right here. If I'm 2.25.6, I would rather round up into the right area zone here than to round down to where I'm not in the top 10% anymore. Hopefully that makes sense there. But we would round up in all cases here. Even if we're 225.1, I'd round up. So that the lowest possible score to qualify is a 226, assuming that they use whole number scores. All right, so for a medical study, a researcher wishes to select people in the middle 60%. A little bit different there, of the population based on blood pressure. Assuming that blood pressure readings are normally distributed, oh boy, and the mean blood pressure is 120, so mean is the average, is 120. The standard deviation is 8. We're going to find the upper and lower readings that would qualify people to participate in the study. So let's draw our picture here. So this one's a little bit different. Like I said, I want the middle 60%. So what I want what's in there, what's in between those two lines. This is what I want. I want the middle 60%. So if I want the middle 60%, that means there's going to be 30% on each side of this line. There'll be 30% here. There'll be 30% over here. All right, so looking at the left-hand side, well, on the left-hand side here, we know it's that half of it, 0.5, is going to be on the left side. So the question becomes, well, what is left over here? 0.2000 is left over here. All right, so that's going to be one of my reverse lookup values. I'm going to want to look up what's in here. Okay, I want to know what's to the left of this line. I'll find a z-score from there. The other thing I'm interested in is, well, what's to the left of this line? I've got 30% here, 30% here. That's 60, 80%. So I'm going to do two reverse lookups. One for 0.2000, one for 0.8000. 20% of data will fall to the left of this line, and 80% will fall to the left of this line. Got to find the cutoffs on each end. So real quick, let's end the show. Let's look up those values. So 0.2000 first, that'll be a negative z-score. So 0.2000, let's see if we can find it. So it's going to be between these two, 0.2000, 0.2000, Looks like 0.2005 is the closest, certainly closer than 0.1977. So that is negative 0.80. 1, 2, 3, 4. Negative 0.84. Negative 0.84. I'll scroll up to show that. 4. Do I have enough? Just barely. No, I don't. Negative 0.84 right there. So z-score here, negative 0.84. Go right back into the table. 0.80, that's bigger than a half, so it will be a positive z-score. 0.8000. 0.7995 is the closest for sure, and that is positive 0.84. When you want those middles, you really only have to find one, because if it's in the middle, you're going to have the positive z-score and the negative z-score that are the same. So I guess I didn't really necessarily need to do that, but 0.84. So based on that, x sub 1 will equal 120 plus negative 0.84 times 8, which is negative 0.4, 0.84 times 8 plus 120. That's 113.28. And x sub 2 would equal 120 plus a positive 0.84 times 8, which will equal 0.84 times 8 plus 120, 126.72. So now we round these things. We want to make sure that we are in. So 113.28. So we wouldn't want to go down to 113. That would take me out of my range. I would want to go up to 114 to ensure that I'm in the yellow. So take that up to 114. On the other hand, with 126.72, if I round up to 127, that takes me to the right a little bit, which puts me in the white. I want to go into the yellow, so I round to the left to 126. The rounding here can get a little confusing. Do be careful. Make sure you round in a direction that will take you towards the values that you want, not away from them. It will sometimes defy the rounding rules that you're used to. So do be aware of that. Had a little bit of technical difficulties there at the end of the last example, but I do have one more example here. What I'd like you to do actually is to pause your video and see if you can figure this out on your own. All right, make the drawing, label things up, see if you can't figure it out on your own. Go ahead and pause the video now. All right, so we've got a contractor deciding to build homes that will include the middle 80% of the market. So they want to be able to appeal to most of home buyers, the vast majority. If the average size of homes built is 1,810 square feet, think about where that fits into our distribution. That is the average. So mu. Oh, there we go. The average is 1810. Find the maximum and minimum sizes of the homes the contractor should build. Because we want to find the minimum size. So what's the smallest size that would satisfy? The middle 80%. What's the largest size of house that would satisfy the middle 80%? Assume that the standard deviation, sigma, is 92, and that we're normally distributed. So now that I've got my mean and my standard deviation labeled, let me make the drawing. There we go. Right there is 1810. Oops. 1810. Let's see here. So I want to satisfy the middle 80%. So, between about there and there, let's say. It doesn't really matter how we draw it. we want to satisfy the middle. Our goal is to find x1. Should use a, not a cursive S there. Let me go ahead and fix that. There we go. We need to find those. So now we work through our math here. So we've got, if we want the middle 80%, then we're going to have 40% on either side. So 0.4000. Oops, there's a bell. 0.4000. Well, that means in the tails, there are 10% in each tail. So there's going to be 10% in that tail. I'm not really concerned about the right tail. It also has 10% in it. If I were looking for, an upper 10%, I might be interested about this right tail. But if these middle problems, I'm interested in the middle areas as well as this left-hand tail. So my first cutoff is to the left of this. This would be my minimum x value. And so I need to find the z-score corresponding with an area of 0.1000. Let me just go ahead and do that. Keep those annotations. So I'll come into my table. Looking for 0.1000. I know where it's at. It's at negative 1.28 is the best we can do. Okay, we got 0.1003 there. Whereas we got 0.0985 there on the next one. 0.1003 is definitely closer to 0.1000. It's 3 away, while 0.0985 is 15. I guess it'd be 15 ten-thousandths away. At any rate, we're going to select the z-score negative 1.28. And I would bet that x2 is going to be a positive 1.28. Let's just check out how we find that out, though. So we got 40% in this area, 40% in this area. That's a total of 80%, plus the 10% in the tail. That is 90%. So we're looking at 0.9000. And going into my table to the positive z-score, since it'll definitely be more than 0, 1.28, 0.03 away, 0.15 away. This one is closer. Positive 1.28 is the z-score. Now let's full screen this slideshow from current slide. So z2, oh man, is 1.28. Change this over. Boom. So x1 will equal the average, 1810, plus negative 1.28 times 92. 1810 minus 1.28 times 92 is 1692.24. And x sub 2 is 1810 plus a positive 1.28 times 92, which is equal to 1810 plus 1.28 times 92, 1927.76. Again, do be careful with the rounding here. So 1692.24 is my cutoff. If I round down to 1692, I've moved out of my range. So I got to round up. I got to round up into the yellow, up to 1693 to ensure that I'm in that middle of 80%. Same thing here. If I round up to 1928, I'm going to end up in the white. I want to round so that I'm in the yellow, so I round down to 19 27. So my acceptable range is 1693 to 1927 square feet. With that, thank you for watching. Just do want to walk through real quick the upcoming schedule for next week. There's not an assignment due next Sunday. You will be receiving a study guide on Moodle here in the next few hours for sure. It's currently, 8:30. Hopefully be done by noon, no problem. There'll be a live meeting on Monday. That's going to be in Google Meet. I will post that link for you in Moodle. I'll post it in next week, since that technically will take place next week. It'll be from 9:50 to 10:30, so a 40-minute session there for me to answer any questions regarding this second midterm, which covers chapters 5 and 6, what we've covered from those chapters. With that, midterm 2 is going to be posted at about 12:30 p.m. on Monday, and you'll need to have it done by the end of Sunday. The assignments don't really have a time constraint on them. The test does here. It must be completed by Sunday. Anything that's not completed by Sunday will be graded as a 0, so make sure that you get it graded, that you get it done in this window. With that, have a great rest of your day, great weekend. Hope you all are being safe, and hope to see you guys soon.